This is a lesson on solving quadratic equations by factoring. This video is going to differ slightly from the notes that were given in class in that I have some examples that are the same but others that are different. Example 1. We'd like to determine the zeros of the function, the roots of this function, the solutions. Those are all three ways of saying the same thing. So we want to determine where is this parabola crossing the x-axis, at what x values. So the way to do that is to set the quadratic equation equal to 0. What we're saying is where it's crossing on the y-axis are the x-intercepts, and what we know about the x-intercepts are that the y values are 0, and so we put 0 in for the y values. Now, how do we solve this? Well, we can't solve it in the same way we would solve a linear equation, so what we need to do is factor. The factoring part of this goes back to our previous unit on factoring, and if you're having trouble with that, you need to go ahead and practice that again. So I'm going to walk through a few different ways of solving by factoring. In this case, we look and see how many terms are in the expression on the right-hand side of the equation, and we've got 3 terms, x squared, x, and constant, so that we know that it's a trinomial method. Take a look. The x squared has a coefficient of 1, so you know that it's the simple method. So you say simply to yourself, what multiplies to 8 and adds to 6? The answer is 4 and 2, and so we can right away factor that into x plus 2 and x plus 4. Now at this point what we're saying is, hey, we've got 2 factors that multiply to make 0. If that's the case, we know that one of them needs to be 0. Therefore, either the x plus 2 part comes out to be 0, or the x plus 4 part comes out to be 0. And so what we do is set each of those factors equal to 0 and figure out what would the x need to be to make that into, to have that come out to be 0. And so we solve each of those like we would solve any equation, and we get x equals -2 and x equals -4. Therefore, the zeros of this function are -4 and -2. Example 1.5. This is one that's different from the note sheet. All right, same situation here. If we're trying to determine the solutions to this quadratic equation, we first set it equal to 0, and then we need to factor. Now, don't make the factoring more complicated than it needs to be. When we take a look at this, there are 2 terms, so we have 2 possibilities. One is difference of perfect squares, and that's definitely not the case here. So the other is greatest common factor. Don't forget about that as a means of factoring. These two terms have a common factor. They have a factor of 3x in common. So we're going to factor out a 3x, and we're left with x plus 7. So we're in a situation where we've got 2 factors multiplying to make 0. So we want to set each of them equal to 0, just like we did before. So we have either the 3x part makes 0, or the x plus 7 part makes 0. In solving each of those, in the first one, we're going to divide each side by 3. In the second one, we're going to subtract 7 from each side, and we end up getting x equals 0, or x equals -7. So the zeros of this function are 0 and -7. Example 2b, again, this one's slightly different from the note sheet. Same situation. We want to figure out the solution, so we set it equal to 0. How do we factor this? Well, I do recognize right away that there is a greatest common factor of 5. So I'm going to factor out a 5, and I'm left with x squared minus 4. That factor of x squared minus 4 is still factorable because I see that that is difference of perfect squares. So I realize that I can factor that part into x plus 2, x minus 2. So now we've got 3 factors that multiply to make 0. So at least one of them has to come out to be 0 to make that true. And I realize that the 5 is just the number 5, and that's not going to do anything for me in terms of figuring out an x value. So I just ignore that for right now, and I set the 2 factors that contain a variable equal to 0. X plus 2 could be 0, x minus 2 could be 0. Continuing to solve, we get x is -2 or 2. So those are my zeros. One last example. Set it equal to 0. When I look at this, I see x squared x constant. That's a trinomial, and the coefficient of the x is a 2, so I know it's not the simple method, that I need to use the AC method. So I say to myself, 2 times 4 is 8. What multiplies to 8 and adds to -9? The answer is negative 8 and negative 1, so I rewrite the expression with a minus 8x and a minus 1x in place of the negative 9x. And then I proceed to factor using the AC method. If you need a review of that, go back to our factoring unit. And I'm left with the factors of x minus 4 and 2x minus 1. I set each of those equal to 0, and I solve each of those as little mini equations, and I end up getting zeros of 1/2 and 4. Here's one more example, and I realize that my animations are not working, but you can just take a look at the whole example right here. We've got another x squared x constant trinomial, but we don't normally factor it very easily when the coefficient of the x squared is a negative number. So the first thing I'm going to do is factor out a negative 1, and then I'm left with a trinomial that's the simple method. What multiplies to negative 3 and adds to 2 is 3 and negative 1. So those are my three factors. The negative 1 factor doesn't do anything for me in terms of determining an x value. So I set x plus 3 and x minus 1 equal to 0. Solve those. The zeros of this function are negative 3 and 1.